Hello everyone, welcome to today's video. Today we will learn about quantum mechanical model of the atom. In this video, we will learn about what was the need for a new atomic model, dual nature of matter, de Broglie hypothesis, Heisenberg uncertainty principle, Schrödinger wave equation, wave function and probability interpretation, concept of orbitals and orbits. And at last, we will learn about quantum numbers and their significance. In previous video, we have learned in Bohr's model, electron revolve in a fixed circular path called orbits or energy level around the nucleus. Each orbit has fixed energy, so electrons in these orbits do not lose energy while revolving. But electron can jump between energy levels. When an electron absorbs energy, it jumps to a higher energy level, which is called excited state of that electron. And when it loses energy, it jumps back to the lower energy level, that is releasing light. So Bohr's model explains the stability of atom and spectral line of hydrogen atoms. But there are few limitations of Bohr's model, like it could not explain spectra of multi-electron atom, and it could only explain hydrogen and hydrogen-like atoms. It is failed to explain complex atom and wave nature of electron. It also failed to explain the fine structure and splitting of spectral line like Zeeman effect or Stark effect. So what is Zeeman and Stark effect? Actually, electron create a magnetic field because it spins around its own axis, which is called spin, and its orbit around the nucleus, which is called orbital motion. So these two motion make the electron behave like tiny magnet. It creates magnetic movement. So we can say that electron magnetic movement is a measure of magnetic strength and orientation of an electron due to its charge and motion. So, in a magnetic field, the energy level is split into multiple sublevels due to interaction with its magnetic movement. This is called Zeeman effect. In an electric field, energy level is split due to interaction with the electron's charge and electric field, because Bohr's model had only fixed energy level based on orbital radius and no electron cloud concept, because Bohr's model did not include electron spin, magnetic interaction, orbital orientation in space. So it could not explain why and how a single spectral line is split into multiple lines in a magnetic field. And what is a Stark effect? So it could not explain why energy level is split under an electric field. So what we can say, splitting of electron energy level due to interaction of magnetic movement and magnetic field is called Zeeman effect, and splitting of electron energy level due to interaction of electrons charge and electric field is called Stark effect. Bohr's model is too rigid and classical, while quantum mechanics is more flexible and realistic. It treating electron as wave like cloud with certain position. This means that electrons are not just tiny particles but also behave like waves spread out in space. It also could not explain Heisenberg uncertainty principle. I will explain this ahead a little later in the video. And it also violated principles of quantum mechanics. At last, I will elaborate this topic as we progress. So here are new discoveries that demand a better model. First is wave-particle duality, de Broglie hypothesis, which says electrons behave both like particles and waves just like light. Heisenberg uncertainty principle, which say it is impossible to know the exact position and momentum of an electron at the same time. And the quantum mechanics, which introduced a new way to study very small particles. It focused on probabilities, not certainties. And due to these new discoveries, a new model was needed, which consider a wave nature of electron, describes electron position in terms of probabilities, which work for all atoms, not just hydrogen, and which is based on quantum mechanical principles. Now, we will discuss new discovery wave particle duality, de Broglie hypothesis, which demand a better model of an atom. A French scientist who proposed that matter has a dual nature. It behaves like both a particle and a wave. Bohr's model assumed that electron had a fixed position and fixed speed in an orbit. So, scientists believed matter like electron and proton behave like particles and light behave like wave. But then experiment like photoelectric effect showed that light also behave like a particle, which is called photons. This made scientists wonder. He thought that if light can behave like a particle, can particle behave like a wave? A French scientist who proposed that matter has a dual nature, that is, it behaves like both particle and a wave. So, de Broglie hypothesis says every moving particle has an associated wave, which is called matter wave or de Broglie wave. So, de Broglie wavelength formula is lambda is equal to h upon mv, where lambda is the wavelength of the particle, h is the Planck constant, m is the mass of the particle, and v is the velocity of the particle. So what is Planck constant? Planck constant is a fundamental constant in physics that shows the relationship between the energy of the photon and the frequency of its wave. So let's see how this equation derives. Lambda is equal to h upon m v, where h is the Planck constant, m is the mass of the particle, and v is the velocity of the particle. For light, Einstein showed that E is equal to h nu, where nu is the frequency. So as we know, nu is equal to c upon lambda. C is the speed of light, which is 3 into 10 to the power 8 meter per second. This is the equation 1. Now put the value of nu in equation 1, then we will get E is equal to h c upon lambda. This is the equation 2. Now use the relation between energy and momentum for photon. So E is equal to Pc. This is the equation 3. So we will get the two equation. E is equal to hc upon lambda and E is equal to Pc. So we can write hc upon lambda is equal to Pc. So C will be cancelled. Now we will get P is equal to h upon lambda. Then lambda is equal to h upon P. Now we know that P is equal to, P is the momentum. P is equal to mv. Now put the value of P over here, then we will get lambda is equal to h upon mv. So this is the expression for de Broglie hypothesis. Later in 1927, Davison-Germa experiment confirmed this idea. They saw that electron when passed through the crystal, it creates diffraction pattern, just like wave do. So de Broglie hypothesis changed the way we look at matter, not just as particle, but as entities that also behave like waves. This laid the foundation of quantum mechanics. Next discovery is Heisenberg's uncertainty principle, which supports quantum mechanics. It is impossible to know exactly both the position and momentum of a particle at the same time. This idea was proposed by Werner Heisenberg, and it is one of the key foundation of quantum mechanics. In simple word, if you try to find out where particle is, that is its position, you will be less sure how fast and in what direction it is moving. That is its momentum. And if you try to measure its momentum very accurately, its position becomes uncertain. Why does this happen? Because particles like electron behave like waves, as de Broglie says. You cannot point an exact spot on a wave. It's spread out. It shows electron cannot have fixed orbits like Bohr's imagined. Instead, we use orbitals, where there is high chance of finding the electron. It leads to the development of quantum mechanical model of atom. So what is the mathematical expression for Heisenberg uncertainty principle? This is delta x, delta p is greater than or equal to h upon 4 pi, where h is the Planck constant, delta p is uncertainty in momentum, and delta x is uncertainty in position. We won't go deep into its mathematical derivation today because it is based on advanced wave mechanics and beyond our current syllabus. So for now, we will focus on understanding what it means. So it is impossible to simultaneously determine the exact position and exact momentum of a particle, like an electron, with perfect accuracy. To better understand the behavior of electron as wave, we use a very important equation developed by Erwin Schrödinger. It is called Schrödinger Wave Equation. It is the foundation of quantum mechanics. It describes how the wave function of a particle change with position and time. It helps us to understand the behavior of electron inside an atom, where they are likely to be found and how they move. So the expression for Schrödinger wave equation is h bar psi is equal to E psi, where h bar is the Hamilton operator and E is the total energy of the system, and here psi is the wave function. Here, the Hamilton operator is like in maths, plus, minus, multiplication, division. It does double differentiation of any variable. Like if I want double differentiation of function x with respect to y, then we will get d square x upon dy. So this is the double differentiation of x with respect to y. So it is a complete differentiation. If we want partial differentiation, then we use Hamilton operator. It does double differentiation of psi. On solving this equation, we will find d square psi upon dx square plus d square psi upon dy square, d square psi upon dz square plus 8 pi square m upon h square E minus V is equal to E minus V psi is equal to 0. So here is the double differentiation of psi in all three directions. That means electron has three amplitude which is different in all three directions because electron move around the nucleus in three directions. So the Schrödinger wave equation is a detailed mathematical description of how particles behave at the quantum level. Since it is derivation and full explanation involve advanced mathematics that's usually covered at the engineering and postgraduate level. So we won't go into the full detail here. Instead, we will focus on understanding what it means. So in this equation, h is the Planck constant, m is the mass of the electron, psi is the wave function which describes the electron's behavior in atom. V is the potential energy and E is the total energy of electron and x is the position. So when you solve this equation with respect to any atom, you will find the value of three variables x, y and z. These values tells us the exact value of an electron. They are like coordinates. Like in maths, with the help of coordinates, you can plot a graph in 3D graph. In Schrödinger equation, the coordinate x, y, z in 3 dimension simply represent the position in space. For example, imagine a tiny ball trapped in a small box. The ball can only move back and forth inside the box. That means its position is limited to the length of the box, which we call x, the coordinate. The Schrödinger wave equation uses this coordinate x to find the wave function, which tells us the probability of finding ball at different positions inside the box. So the coordinate x is just like a location marker along the box. Another example that we can take is guitar. Like in guitar, string fixed at both the end. The position along the string determines how the string vibrate. Some points vibrate a lot, some don't vibrate at all. Schrödinger coordinate works similarly, marking where in space the particle wave can be strong or weak. In this equation, we use a term wave function. What does it mean? Like if electron has some momentum, then it also possesses a wavelength associated to its wave. So suppose an electron is moving around the nucleus in 3 dimension. Like electron is moving around the nucleus in 3 dimension. We can show it like, then it must have some amplitude. This is psi. So the maximum height of the amplitude of wave is called psi because electron present in all three directions. That is, its wave present in all three directions. So it is impossible to locate an electron. So Schrödinger says that we cannot find the exact location of an electron, but we can find the probability of finding an electron. So psi does not give the exact position of the electron, but psi square gives the probability density of finding an electron at a certain point. This led to the concept of orbitals. That means the region in space where the electrons are most likely to be found. Wave function must be finite, single valued or continuous.
So what a Schrödinger equation does? It tells how electron behave like wave inside an atom. It replaces the idea of fixed orbits like Bohr model with the orbitals. It introduces quantum numbers and energy level more accurately. Why this equation is important? Because it explains atomic structure much better than Bohr's model. It helps us understand the chemical bonding, shapes of molecules, and periodic trends. It laid the groundwork for modern quantum chemistry and physics. Now that we have seen the Schrödinger equation, when we solve this equation, we obtain a set of values called quantum numbers. These numbers give us detailed information about electrons' state. So let's understand quantum numbers and what each of these means. First is principal quantum number. It is denoted by n. It describes the location and energy of an electron in an atom. It tells us the main energy level or shell of electron. Like this is the nucleus of an atom and these are the energy level or shells of an atom in which electrons are present. These energy levels are named as K, L, M, N, and so on. These shells can also numbered as 1, 2, 3, 4, and so on. It tells us how far the electron is from the nucleus and how much energy of the electron has. If the value of n is 1, that means it is the first shell of an atom, that is K. If the value of n is 2, that means it is the second shell of an atom, that is L. If the value of n is 3, then it means it is the third shell of an atom, M. So higher the value of n, higher the energy and farther from the nucleus. The energy of an electron in nth orbital or shell can be calculated as En is equal to minus 13.6 into Z square upon N square. EV, electron volt. So here negative sign shows that electron is bound to the nucleus. Here Z is equal to atomic number and N is equal to shell number. This formula comes from Bohr's atomic model and help us to calculate how much energy of an electron has in any given orbital. The derivation is quite complex and mathematical, so we won't go into that right now. Instead, we will focus on how to use the formula. For hydrogen-like atoms like helium, the atomic number of helium is 2. Because there is plus charge, so it has lose its one electron. So only one electron left in the shell, which is in the first shell of that atom. So the value of N is 1. Now, how we calculate the energy of that electron? We will use the formula E is equal to minus 13.6 into Z square upon N square. Minus 13.6, the value of Z is 2. So we will put the value of Z here. And now we will put the value of N. By solving this, we will get the answer minus 13.6 2 square, that is 4 upon 1. On solving it, we will get the answer minus 54.4 electron volt. In the same way, in case of lithium plus 2, here the atomic number of lithium is 3. And because there is plus 2 charge, it has lost its 2 electron. So only 1 electron left in the first shell of an atom. The value of N will be 1. Now we will calculate the energy of that electron is minus 13.6. Put the value of Z 3 square upon, now put the value of N minus 13.6 into 9 upon 1, and we will get the answer minus 122.4 electron volt. So N represent principal quantum number. We can understand it like we can think of an electron like floors in a building. If N is equal to 1, that means ground floor. N is equal to 2, that means first floor. If N is equal to 3, that means second floor. You can memorize it like higher floor is equal to more energy, more space. Next is azimuthal quantum number. It is also called angular momentum quantum number, and it is denoted by L. It is also called angular momentum quantum number. It gives information about subshell and the shape of orbital. For the given principal number n, the value of L will be 0 to n minus 1. The shapes of orbital based on L. Like if the value of L is 0, then it will be s orbital, which is spherical in shape. If the value of L is 1, then the shape of orbital will be dumbbell shape. And if the value of L is 2, that is d orbital, which is double dumbbell shape. And if the value of L is 3, then it is f orbital, which is complex. We will discuss about the shape of orbitals in next video. So here we will discuss only about what is azimuthal quantum number and how we calculate the value of L for a given electron. So if n is 1, then L will be 0. If n is 2, then L will be 0, 1. If n is 3, the value of L is 0, 1, 2. If n is 4, then L will be 0, 1, 2, 3. Like here in this spec, I mentioned the energy level or shells of an atom, which is named as K, L, M, N, and so on. For the first shell, subshell will be 1s. For the second shell, subshell will be 2s, 2p. For the third shell, subshell will be 3s, 3p, and 3d. For the fourth shell, subshell will be 4s, 4p, 4d, and 4f, and so on. The azimuthal quantum number L tells us which subshell the electron has and the shape of the orbital in which it move. The orbital angular momentum is the momentum an electron has due to its motion around the nucleus in an orbital, just like how the Earth moves around the Sun. So, the expression for the angular momentum of an electron is L is equal to h upon 2 pi under root L L plus 1, where L is the orbital angular momentum L is the azimuthal quantum number and h upon 2 pi is the reduced Planck constant, which has value 6.626 into 10 to the power minus 34 Js. Suppose we need to find angular momentum of an electron in 3p subshell. Then how we calculate? Angular momentum of an electron L is equal to h upon 2 pi under root L L plus 1. In 3p subshell, the value of n is 3. That means the electron is in third shell and the value of L is 1 because for the value of L 0, 1, 2, 3 S, P, D, F. So here for P subshell the value of L will be 1. Now put the value 6 point h upon 2 pi is the reduced Planck constant. So the value of Planck constant will be 6.626 into 10 to the power minus 34 under root 1 1 plus 1. Now solve it. 6.626 into 10 to the power minus 34 under root 2. It is not directly speed, but more like how strongly the electron orbits. Next is magnetic quantum number. It is denoted by m. It tells us how many orbitals are there in a subshell and their orientation in space. The number of orbitals within a subshell like SPDF and the orientation of these orbitals in 3D like in X, Y and Z direction. The value of m for given L is minus L is greater than or equal to m is smaller than or equal to plus L. Or in other words, we can say for any given L, the magnetic quantum number m can start from minus 1, increase in step of 1 and end at plus 1. And the total number of m for given L is total number of m for given L is 2L plus 1. For example, if L is equal to 0, that means S subshell M values 0 only. And the total number of M is 2L plus 1. That is 2 into 0 plus 1. That is 1 only. And if L is equal to 1, that is P subshell. For P subshell, M values -1, 0, plus 1. We will get it by using the formula minus L is greater than or equal to M is smaller than or equal to plus L. So for P subshell, the value of M is -1, 0, plus 1. And the total number of M will be 2L plus 1. That is 2 into 1 plus 1. So the total number of M will be 3. Because we have already studied that if L values 0, that means S subshell. If L values 1, that means P subshell. If L values 2, that is D subshell. And if L values 3, that is F subshell. So for P, the value of L will be 1. That's why here I put the value 1, because there is P subshell. If L values 2, that means D subshell. M values for D subshell is -2, -1, 0, +1, +2. And the total number of M is 2L plus 1. That means 2 into 2 plus 1. That is 5 orbitals. So, in simple words, we can say that magnetic quantum number tells us how many orbitals are in subshells and in which direction. Like for P subshell, there are 3 orbitals: Px, Py, and Pz. And M values 0, -1 to +1. So for P subshell, M is indicated like -1, 0, +1. And total number of M can be calculated by using this formula 2L plus 1. So there are total 3 orbitals in P subshell. Next is spin quantum number, which is denoted by S. It tells us the direction of spin of an electron inside an orbital. It describes the intrinsic angular moment, that is, spin of an electron either clockwise or anti-clockwise. Actually, electrons do not literally spin. It's just a quantum property. It is important because every orbital can hold 2 electrons, and these 2 electrons must have opposite spins. This is called Pauli exclusive principles, which says no 2 electron in an atom can have the same set of 4 quantum numbers. That means each electron in an atom is uniquely identified by 4 quantum numbers. principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. So each orbital can hold a maximum 2 electrons. All 4 quantum numbers can be same, but fourth quantum number must have opposite spin. If we are taking an example of helium, its atomic number is 2. So it has 2 electrons. Its electronic configuration is 1s2. For these 2 electrons, the value of n, that is principal quantum number, will be 1. And the value of azimuthal quantum number is 0, because this orbital placed in s subshell. So for s subshell, the value of L is 0. So for both the electron, the value of L is 0. And the magnetic quantum number M is also 0 for both the electrons. Now, if we are moving to fourth quantum number, that is a spin quantum number. So as we know that every orbital can hold only 2 electrons. So in s orbital, spin quantum number for one electron is plus half, and for the other electron, the spin quantum number is minus half. So as we saw that all three quantum numbers are same for both the electrons, but the fourth quantum number was different. Now, this is the diagram showing shells and subshell and maximum number of electron in each shell. Let's now understand the structure of an atom by looking at how electrons are arranged in different shells and subshells. Atoms have different energy levels or shells named as K, L, M, and so on. Each shell made up of subshells. These are S, P, D, and F. Depending on the shell, the number and types of subshell in each shell increases with the value of n. For example, K shell has only one subshell. L shell has two subshells. M shell has three subshells. And N shell has four subshells. So each subshell can hold a fixed number of electrons, like S can hold 2 electrons, P can hold 6 electrons, D can hold 10 electrons, and F can hold 14 electrons, because S has one orbital, P has 3 number of orbitals, and D has 5 orbitals, and F has 7 orbitals. So maximum number of electron each shell can hold is K can hold 2 electron, L can hold 8 electron, M can hold 18 number of electrons, and N can hold 32 number of electrons. These values comes from the formula 2n square. This shell and subshell structure help us write the electronic configuration of atom. So we will take up electronic configuration in the next part. Let's first understand the basic. So quantum numbers are like an address in a big housing society. The principal quantum number is the society name, the azimuthal quantum number is the block, and the magnetic quantum number is the flat number. And the spin quantum number, we can consider it like whether the person is facing left or right. So just like an address tells you exactly where someone lives, in the same way quantum numbers tells us exactly where an electron is. So we have understood how to locate an electron using quantum numbers. In my next video, we will explore the shape of the orbitals, like the shape of S, P, D, and F, and see how electrons arrange themselves in this unique space. Now we have understood the concept, so let's try a few practice questions to make the concept more stronger. So here's the first question. How many subshell and orbitals are present if n is equal to 3? So as we know, number of subshell is equal to the number of shell. So if n is equal to 3, that is number of shell is 3. So number of subshell will be equal to the number of shell. So the subshell will be 3. That is 3s, 3p and 3d subshell for the third shell. And how many orbitals are present if n is equal to 3? So as we know, s has 1 orbital, p has 3 orbital, d has 5 number of orbitals. So the total number of orbitals will be 9. We can also calculate number of orbitals by using the formula n square. So if the value of n is 3, then the number of orbitals, total number of orbital in third shell will be 9. Next question is, find the number of orbitals if n is equal to 2. So if this is the nucleus and these are the shells where electrons are supposed to be present. So if n is equal to 2, we named it like K, L, M. So we are talking about second shell. N is equal to 2. For this shell, number of orbitals will be n square. That is 2 square. So total number of orbitals will be 4, because for the second shell, number of subshell will be 2s and 2p. And as we know, s has 1 orbital and p has 3 orbitals. So total number of orbitals will be 4. Third question is, find the number of electron in second shell. So how we calculate the total number of electron? So if n is equal to 2, that means subshell will be 2s and 2p. So as we know, s has 1 orbital and p has 3 orbitals. And we know that each electron can hold only 2 electrons. So there are 2 electron in s orbital and 2 electron in this orbital, px, py and pz. So total number of electron will be 8. We can also calculate the total number of electron in second shell by using the formula 2n square. That is 2. Now put the value of n, which is 2, on solving. We will get 8 number of electron. Next question is, find the number of electron in fourth shell. That means the value of n is 4 and the total number of electron in fourth shell is 2n square. That is 2 and the number of shell is 4. That means 32 number of electron. We can also find the number of electron in the fourth shell, like if n is equal to 4, then 4s, 4p, 4d and 4f. So s has 1 orbital, p has 3 orbital, d has 5 number of orbitals and f has 7 number of orbitals. Each orbital can hold only 2 number of electron. So we can fill 2 electrons in each orbital. Now calculate all the number of electrons that we fill in each orbital, and the answer will be 32. Next question is, how many orbitals are there in D subshell? So as we know, for each subshell, S, P, D and F, value is 0 for P, 1 for D, 2 and for F, 3. For D subshell, the value of L will be 2. So we can calculate the number of orbitals by using the formula 2L plus 1. Now put the value of L, 2 into 2 plus 1. That is, total number of orbital in D subshell will be 5. Now the next question is, how many electrons can be present in all the orbitals of the 3D subshell? We can solve this question by using the formula 2, 2L plus 1. So here for D, the value of L will be 2. Now put the value of L, 2 into 2 plus 1. That is 10 electron. So total number of electron present in 3D subshell will be 10. We can also find the number of electrons, like as we know that D subshell has 5 number of orbitals, and as we know each orbital can hold only 2 electrons. So total number of electron will be 10. Now to make it easier, I am arranging all the formulas at one place. That will help us to solve the questions faster. So that's all for today's video. I hope you understand the concept well. In the next video, we will take a quick revision of quantum numbers and study how to write electronic configuration of any element. So stay tuned. Thank you for watching. Keep learning, keep practicing, and I'll see you in the next video. Bye bye.